Welcome to Algebra 1 CST release question number 75. It says the height of a triangle is 4 inches greater than twice its base, and the area of the triangle is 168 square inches. What is the base of the triangle? Sure sounds like a draw a picture type of problem to me. So I'm not going to draw this to scale necessarily, but I'm going to say that this will be my base and this will be my height. They're perpendicular to each other. It might not be a right triangle, but I'm going to draw it so that it looks like one. It doesn't say what type of triangle it is, so I don't feel like that's an important part of this problem. What's important is that we label things correctly here. So the height of the triangle is 4 inches greater than twice its base. So if the base, I call B for base, I know the height of the triangle is 4 inches greater than twice that. So this is definitely not drawn to scale. This would be twice the base, 2b, plus 4. This would be much bigger than this. It also says the area, which I will label the capital A, is 168 inches squared. And so I know the area of a triangle, of any triangle, is 1/2 base times height. But I can plug in 168 for the area. I know that's what it is. And I can also plug in, I know my base is represented by B, but my height is represented in terms of the base. In terms of the base, it is 2b plus 4. From there, I've got 168 equals 1/2 b. I'm going to take this and distribute it to both parts here. The 1/2 b distributed to both parts will look like this. It would be b squared plus 2b. Subtracting 168 from both sides leaves me with 0 equals b squared plus 2b minus 168. And it looks like this might be factorable. So let's try to factor this out. I've got b here and here. That would have to be the right combination there. What are the factors of 168? That's not easy to do off the top of your head. So let's try a little factor tree method here. Let's break it down. So I know 2 is going to go into there. It's even. This would be 34, 84. Okay, so 84. And then 84, I know some multiples of 84. I know 7 times 12 gives me that. So I can keep breaking this down if I wanted to in this way. But I know then that these are all, this is the prime factorization of this, so I can use these numbers or combinations thereof, multiples of these numbers, like 2 times 7 would work. So I could try these different things. I need to have something pretty close to each other. So if I did the 2 times 7, that would give me 14. And the 2 times 2 times 3, that would give me 12. And I notice, these are 2 apart from each other, just like this needs to be 2 apart from each other. So if I did minus 12 in one spot and plus 14 in another spot, when I FOIL that back out, it's going to give me what I see there. So from there, I've got 0 equals, I can set both of these parts equal to 0, both of these factors equal to 0. I don't actually need to write that out here. I've got b minus 12. What's going to make this factor equal to 0? 12, clearly, I think. Again, you can do b minus 12 equals 0 and solve for b if you want to. And right here, what's going to make this factor equal to 0? 14, but negative 14. What's a possible height? Can you have a negative height or a negative base, in other words? Or is what I meant to say a negative base? No, you can have a positive value for the base, a positive value for a distance. So the negative 14 just doesn't make sense because it's negative. 12 has to be the answer, so your answer should be 12 inches for number 75. Choice C for 75.